Section 8.3 is about circles. A circle is a set of all the points in a plane that are equidistant, which means the same distance from a given point. That's called the center. Here you see in blue a circle. Here's the center. Now this line that we draw from the center to the outside of the circle, that's the same distance all the way around. That's called the radius. The equation for a circle you see down here is x minus h, quantity squared, plus y minus k, quantity squared, and that equals r squared. The h and k is your center, and the r is your radius. Here we want to find the equation of this graph. So we'll start with the equation of a circle, and what we need is the h, the k, and the r. Well, the h and the k are the center. So this center of this circle is at 3, -1. So my h will be a 3, my k will be a -1. And if you go from the center to the outside edge, you'll find that the radius is a distance of 3. So with those three values, I can write my equation of this circle, x minus h squared plus y minus k, since k is a -1, minus a negative is a plus, and that's going to equal r squared. That should be a squared, and when you square 3, you get a 9. So this is my equation for my circle. Here we're asked to find the equation of a circle, but all we know is that the endpoints of the diameter are on spot 5, 4, and -2, -6. And if I just do a quick sketch of this, and I imagine that one of the endpoints is there and the other one's down here, what we're saying is we have this circle that goes through these points. That's a really bad circle, but you get the idea. And the diameter is right there. So if we find the midpoint of that diameter, that would give us the center of the circle. And we know how to find midpoints because we have a formula for that. So we're going to find the center of our circle, our HK, by using the midpoint formula. So we're going to add the x's and divide by 2. So that's going to give us a 5 plus -2. Divide that by 2. So we get a 3/2 for our x-coordinate. And then we'll add the y's, 4 plus -6. And divide that by 2, so that's a -2 over 2, which is a -1. So we now have found the center of our circle at 3/2, -1. Now if we want to find the radius, because that's the other value that we need to find the circle, we need the radius, we could find the distance from the center of our circle to one of our endpoints. And if we found that distance, that would be our radius. So we can use the distance formula for that. And so I'm going to find the distance between my center and the point 5, 4. So I'm going to subtract my x values, 3/2 minus 5, and square that. Then I'm also going to subtract my y values, -1 minus 4, and we'll square that. So here we get the square root of 49/4 plus 25 over 1. I'm going to go up here now and finish my work. Common denominators make this a 49/4 plus 100/4, changing 25 over 1 to 100/4. So you end up with the square root of 149 over 4. And that's what r is. Which means r squared is going to be 149 over 4 without the square root. And that's important because you need r squared in the equation of a circle. So here we have the general form for the equation of a circle. I need h, k, and the radius. Well, I have my h, which is 3/2. And I have my k, which is -1. So when we subtract -1, this is going to be a +1. And we know that r squared is 149 over 4. So this is the equation of the circle that has the endpoints on the diameter at 5, 4, and -2, -6. Here we have a definition of a new word called a tangent. A tangent is a word that describes a line that intersects a circle at one point. Well, the only place that a line could touch a circle in only one point would be right along the edge. So let's take a look at that with this example. We want to write the equation of a circle that has a center at -4, -3. which is here, and is tangent to the x-axis, which means it touches the x-axis in only one place. Well, here's the horizontal x-axis, which means the circle must touch it right there. That's where the circle must touch the x-axis, which means that the radius of my circle is 3. But that also means I'm going to have points here, here, and here around the circle, as well as on the x-axis right there. So that should help me sketch my circle a little bit better. So there's a sketch of my circle. The point that it's tangent to is right there. It touches the circle in one spot. And this gives me enough information for me to write my equation. So here's the general equation for a circle, and I can see my center is at -4, -3. So my h is -4. Minus a negative is a plus. My k is -3. Again, minus a negative is a plus. And now I can see from this sketch here that my radius is 3 units. And when you square 3, you get 9. So this is the equation of a circle that has center at -4, 3 and is tangent to the x-axis. Here we're asked to find the center and the radius of a circle with this equation, and then we're asked to graph it. Well, here's the general form for a circle. So if we compare our equation to that, we can see that our h and our k are zeros. So we know the center of our circle is at 0, 0 at the origin. So I'll put a dot here. We also know that r squared is 25, which means that the radius has to be a 5. Which means I know that I have a dot up 5, to the left 5, down, and to the right 5 units. We could probably find a couple more points to make the graph of this circle a little bit better. Well, I know that if I put a 3 in for the x and a 4 in for the y, I know that 3 squared plus 4 squared is 25. So that tells me that I have an ordered pair at 3, 4. So I can go over here and say there's an ordered pair at 3, 4. But because circles are symmetrical, I know that there's also got to be a point that's 3 units to the left of the y-axis, because it's symmetrical with respect to the y-axis. It's also symmetrical with respect to the x-axis, so I know that there's also a point that's 4 units on the other side of the x-axis. And then there also has to be one down here in quadrant 3, because it's symmetrical on the x and the y-axis. Now I also could put in a 4 and a 3 and get the same numbers, so I know there's a point here at 1, 2, 3, 4, 3, and then I can play my symmetrical game again. There has to be one over here, down below the x-axis, and then again over there. So just by plugging in a point 3, 4 or 4, 3 and then using symmetry of a circle, I can graph a pretty good circle here. And so there's the graph of my circle. I know that my center was 0, 0. I'm going to label that, and I knew that my radius here was a 5. Here again we're asked to find the center and radius, but this time our equation is not in the standard form. So I'm going to have to use completing the square to get it there. I'm going to rewrite this by collecting the x's. And then I'm going to leave some room, and I'm going to collect the y's, y squared plus 8y. And then I'm going to leave some room and put the 5 on the other side. I'm going to add the 5. The reason that I'm doing this is because I'm going to complete the square to find out the value that goes here, that completes this trinomial, and here to complete this trinomial, and make them perfect squares. So here I'm going to take half of b, which is -2, and square it is 4. So I'm going to add a 4 and make this a perfect square trinomial. But if I do it to the left side, I have to add 4 to the right side. Likewise, in this one, I'm going to take half of b, which is 4, and square it, so plus 16. And if I do it to the left side, I have to do it to the right side. So now I've created 2 trinomials that are perfect square trinomials. So this factors to be x minus 2 squared. And then this trinomial factors to be y plus 4 squared. And then everything here on the right-hand side is a 25. Now I have an equation that's in the general form for a circle. So I can find my hk a lot easier now and see my h is a 2 and my k is a -4. So that's the center of my circle. 2, negative 4. I also see that r squared, and I should have written this as an r squared, but my r squared is 25, which means my radius of this circle is a 5, just like it was in the last one. Now, because this is a radius of 5, this is actually the same circle as my last example, except this is translated to the right 2 and down 4. It's no longer on the center. So I could go through the whole process of finding points like I did before and plug in 3, 4, and 4, 3 like I did in the last example, but treat this as if it was the origin. So if I did that, I'd get a point here, here, and then on the other side, there and there. And if you don't know what I'm doing right now, look back at the last example and you'll see how I'm getting these points. I'm using symmetry and as if this were on the origin. And so now I can graph my circle. So here we'll label our center at 2, negative 4, and we knew that the radius of our circle was 5, and then we sketched our circle using some other points.